How's it going, everyone? In this video, we're going to be talking about the empirical rule. So the empirical rule is a description of some properties of the normal distribution. Now, just as a recap, when you're dealing with a continuous random variable, the probability of being between two values, let's say x1 and x2, the probability of observing a value between those two values is the area under the curve between those two values. We're going to be talking about that a lot in this video. So, in a normal distribution, you have your bell-shaped curve, and the location of the peak depends on your mean value, and the width of that peak depends on your standard deviation. Now, as your x value gets farther and farther from mu, whether it's getting bigger or smaller, eventually your normal distribution and the probability of observing such an x value gets very, very, very small. Very, very close to zero. It never gets to zero. It goes to positive infinity and negative infinity, but it gets very, very close to zero. Now, empirical means just something that we observe. And what we observe is that if you go 3 standard deviations from the mean value, whether it's plus 3 standard deviations or minus 3 standard deviations from the mean value, if you're dealing with something that follows a normal distribution, pretty much all of the data is going to be within that range. So the area under the curve within that range is going to be almost equal to 1. It's going to be a little bit less, but almost equal to 1. So pretty much all of your data is within 3 standard deviations of the mean value. To be more specific, approximately 99.7% of the data is going to be within your mean value plus or minus 3 standard deviations. Okay. Now, what if we look at other whole number intervals of the standard deviation? Well, approximately 68% of your data is going to be within the mean value plus or minus 1 standard deviation, and approximately 95% of your data is within the mean value plus or minus 2 standard deviations. That's the empirical rule right there. So if you're looking at a random variable that follows the normal distribution, and the normal distribution is so common in nature that in many situations it's considered okay to just assume that your random variable follows the normal distribution. In that situation, if you know the mean value, you know the standard deviation, you can expect that 68% of the data will be, or of the reality based on your data, will be within 1 standard deviation of the mean, 95% will be within 2 standard deviations, and 99.7%, pretty much all of it, will be within 3 standard deviations of the mean value. Now these are rounded values. The exact values are, extend into more decimal places, but these are the approximate values that are easy to remember. So if you've heard the term 3 sigma or 6 sigma before referring to some things, where do these terms come from? Well, if you've got minus 3 standard deviations in one direction and plus 3 standard deviations in one direction, often what is outside of those bounds, what is outside of 3 sigma, is considered an outlier. That entire range has a width of 6 sigma, right? 3 sigma right here, and another 3 sigma right here. So you've heard the term 6 sigma referring to some situations, and that's where that term often comes from. So let's do an example. Let's say there's a test, and it's assumed that the test scores follow a normal distribution. And let's say the average on the test, what was scored on the test, was 65. So the mean value is 65. And let's say the standard deviation was equal to 10. Okay? So 75, 85, 95. And then we have 55, 45, 35. Okay, so this is plus or minus 3 standard deviations, right? We're adding 10 each time. So this is mu plus 3 sigma. This is mu minus 3 sigma, right? That gives you 35. Mu plus 3 sigma gives you 95. Mu itself is equal to 65. So if that's the results that we see, what does the empirical rule tell us? Well, it tells us that we can expect that 68% of students will score in that range 55 to 75. Why 55 to 75? Well, because that is the mean value plus or minus 1 standard deviation. And because probability corresponds to the area under the curve, if we randomly select a student, right, if 68% of students are expected to score within that range, what does that mean? It means if we randomly select a student, there's a 68% chance that the student's grade is within that range. Another way of saying that, the area under the curve of the normal distribution between 55 and 75, the area under that curve is going to be 0.68 approximately. Right? So that's the first part of the empirical rule, that 68% of results are expected to be within the mean value plus or minus sigma, which in our case is 65 plus or minus 10, which is 55 to 75. Now the second part of the empirical rule tells us that 95% of the results are expected to be within the mean value plus or minus 2 sigma, which in our case is 65 plus or minus 2 times 10, or 65 plus or minus 20, which is 45 to 85. So we can expect 95% of results being within that range, 45 to 85. If we randomly select a student, there is a 95% chance, or a 0.95 probability, that their grade is somewhere within that range. And the third part of the empirical rule tells us that 99% of results are expected to be within mu plus or minus 3 sigma. So in our case, that is 65 plus or minus 3 times 10, or 65 plus or minus 30, which is going to be from 35 to 95. So randomly select a student. There's a 99.7% chance, or a 0.997 probability, that their grade is somewhere between 35 and 95, which sounds pretty reasonable. That pretty much all students score somewhere between 35 and 95 on a test. If the average score is 65 and a standard deviation is 10. So, if all you know about a random variable is its mean value and its standard deviation, and it's safe to assume that that random variable follows the normal distribution, you can use the empirical rule to determine what is the range that contains the bulk of the data, what is the range that contains 95% of the data, which is the overwhelming majority, and what is the range that includes pretty much all of the data, so much that you can consider anything outside of that range as an outlier. And that's the empirical rule. So, I hope that helps, and until next time.